Electrical cogeneration and net metering are becoming increasingly common. Let's explore how a consumer's power system integrates with the power company's grid, emphasizing safety. Firstly, the cogeneration system connects to the grid at the consumer's electrical service entrance. Secondly, the system requires protection equipment, including overcurrent protection and anti-islanding relays. Thirdly, a control panel monitors the grid's voltage and frequency, ensuring the cogeneration system operates within specified limits. Fourthly, islanding detection is crucial. Anti-islanding relays detect a loss of the grid and automatically disconnect the cogeneration system. This prevents backfeeding the grid during an outage, which is a significant safety concern. Now let's look at net metering integration. Firstly, a bidirectional meter installed by the utility measures both the power consumed from the grid and the power generated by the cogeneration system. Secondly, the consumer enters into a net metering agreement with the utility. This agreement allows them to sell excess electricity generated back to the grid at a predetermined rate. Thirdly, the utility calculates the bill based on the net amount of electricity consumed minus the electricity generated by the cogeneration system. Fourthly, the cogeneration system must synchronize with the grid. This ensures the generated power meets the grid's voltage, frequency, and phase requirements. Several safety considerations are essential. Overvoltage protection is a must. The system must be designed to protect against overvoltage conditions that may occur if the grid voltage rises above safe levels. Overcurrent protection is equally vital. Overcurrent protection devices prevent excessive currents from flowing through the system, which can damage equipment. Anti-islanding protection, as mentioned earlier, is critical. Anti-islanding relays are required to isolate the cogeneration system from the grid in case of a grid disturbance or power outage. Ground fault detection is another essential safety measure. Ground fault protection devices monitor for ground faults and disconnect the system to prevent electrical injuries or damage to property. Installation and maintenance are best left to qualified professionals. The installation and maintenance of cogeneration and net metering systems should be performed by qualified electrical contractors. These contractors must be familiar with the specific requirements and safety regulations for these systems. Regular inspections and testing are necessary to ensure proper operation and adherence to safety standards. Integrating cogeneration systems and net metering practices with the grid safely and efficiently offers several benefits. Consumers can reduce their energy costs, contribute to renewable energy production, and support the stability of the electrical grid. Let's delve deeper into the specific components and their functions. The grid connection point is where the consumer system physically connects to the utility's grid. This connection point must meet specific requirements to ensure safe and reliable operation. Protection equipment is not just a single device but a suite of devices working together. Overcurrent protection typically involves circuit breakers or fuses designed to interrupt the flow of electricity in the event of an overload or short circuit. These devices are sized appropriately to protect the wiring and equipment in the system. Anti-islanding relays are sophisticated devices that monitor the grid's voltage and frequency. If the grid goes down, these relays quickly detect the change and disconnect the cogeneration system to prevent it from energizing the grid while utility workers are trying to restore power. The control panel serves as the brain of the cogeneration system. It monitors various parameters, such as voltage, frequency, current, and power output. It also provides control functions, allowing the system to be started, stopped, and adjusted as needed. Islanding detection is crucial because backfeeding the grid during an outage can create a dangerous situation for utility workers and the public. It can also damage the cogeneration system itself. The bidirectional meter is a specialized meter capable of measuring the flow of electricity in both directions. It tracks how much power the consumer is drawing from the grid and how much power the consumer is sending back to the grid. The net metering agreement is a legal contract between the consumer and the utility. It outlines the terms and conditions under which the consumer can sell excess electricity back to the grid. This agreement typically specifies the rate at which the electricity will be purchased and any other applicable fees or charges. Billing calculation involves subtracting the amount of electricity generated by the cogeneration system from the amount of electricity consumed from the grid. The consumer is then billed for the net difference. Grid synchronization is a complex process that ensures the cogeneration system's output matches the grid's voltage, frequency, and phase. This is essential to prevent disruptions to the grid and ensure the safe and reliable flow of electricity. Overvoltage protection can be achieved using surge arresters or other voltage-limiting devices. These devices divert excess voltage away from sensitive equipment, protecting it from damage. Overcurrent protection devices are designed to trip quickly in the event of an overcurrent. This minimizes the amount of time that the equipment is exposed to the excessive current, reducing the risk of damage. Ground fault protection devices detect small amounts of current leaking to ground. This can indicate a problem with the insulation of the wiring or equipment, which can be a safety hazard. Qualified electrical contractors have the training and experience necessary to install and maintain cogeneration and net metering systems safely and effectively. They are familiar with the applicable codes and standards, and they can ensure that the system is installed and operated in accordance with these requirements. Regular inspections and testing are essential to identify any potential problems before they become serious. These inspections should include visual checks of the wiring and equipment, as well as electrical tests to verify proper operation. By following these guidelines, consumers can integrate cogeneration systems and net metering practices with the grid safely and efficiently. This can reduce energy costs, contribute to renewable energy production, and support the stability of the electrical grid. In addition, let's discuss some specific scenarios and best practices. Consider a scenario where a consumer installs a solar panel system with net metering. During the day, the solar panels generate electricity, which is used to power the consumer's home. If the solar panels generate more electricity than the home needs, the excess electricity is sent back to the grid. At night, when the solar panels are not generating electricity, the consumer draws electricity from the grid. The bidirectional meter tracks the amount of electricity sent to the grid and the amount of electricity drawn from the grid. At the end of the month, the utility calculates the net difference and bills the consumer accordingly. Another scenario involves a business that installs a combined heat and power or CHP system. A CHP system generates electricity and heat simultaneously. The electricity can be used to power the business, and the heat can be used for space heating or other industrial processes. Any excess electricity generated by the CHP system can be sent back to the grid through net metering. Best practices for cogeneration and net metering include firstly, conducting a thorough site assessment to determine the feasibility of installing a cogeneration system. Secondly, selecting the appropriate technology for the application. Thirdly, designing the system to meet the specific needs of the consumer. Fourthly, ensuring that the system is installed and maintained by qualified professionals. Fifthly, complying with all applicable codes and standards. Sixthly, obtaining all necessary permits and approvals. Seventhly, negotiating a favorable net metering agreement with the utility. Eighthly, monitoring the system's performance regularly. Ninthly, addressing any problems promptly. Tenthly, keeping accurate records of the system's operation and maintenance. Now let's discuss some of the challenges associated with cogeneration and net metering. One challenge is the complexity of the technology. Cogeneration systems can be complex and require specialized knowledge to install and maintain. Another challenge is the cost of installation. Cogeneration systems can be expensive to install, although the long-term savings can offset the initial cost. A further challenge is the regulatory environment. The regulatory environment for cogeneration and net metering can be complex and vary from state to state. Despite these challenges, cogeneration and net metering offer significant benefits to consumers and the environment. By reducing energy costs, promoting renewable energy, and supporting grid stability, these technologies can play a vital role in creating a more sustainable energy future. In summary, integrating cogeneration and net metering with the grid requires careful planning, design, and installation. By following best practices and complying with all applicable codes and standards, consumers can safely and effectively utilize these technologies to reduce energy costs, promote renewable energy, and support grid stability. Remember that safety is paramount. Always prioritize safety when working with electrical systems. Consult with qualified professionals to ensure that the system is installed and operated safely. Keep in mind the importance of regular maintenance. Regular maintenance is essential to ensure that the system operates efficiently and reliably. Be aware of the regulatory landscape. The regulatory landscape for cogeneration and net metering can be complex and vary from place to place. Finally, consider the long-term benefits. Cogeneration and net metering can provide significant long-term benefits to consumers and the environment. These systems need to be tested for acceptance and maintained over time. Commissioning agents may be employed to ensure that the installation meets the design requirements. Proper documentation, including single-line diagrams and three-line diagrams, in addition to the owner's manuals for the gear, are important so that the consumer can reference the documentation in the future. Lockout-tagout procedures are always necessary when servicing and maintaining equipment. Proper personal protective equipment, PPE, is required. This may include safety glasses, gloves, and hearing protection. Arc flash studies can be performed to determine the level of PPE required when working on energized equipment.